Good afternoon, especially to those coming from Europe and Africa. Good morning to those coming from America, and good evening to those coming from Asia and other parts of the world where the evening is now. Welcome again, and it's my pleasure actually to start the second edition of the CrateDB Community Day. So today I'm going to be your host together with my colleague Rafaela. My name is Maria Selakovic and I work as a developer advocate at CrateDB. I'm currently based in Frankfurt in Germany. Rafaela, would you tell us a few words about yourself and where are you now?
Hello, everybody. My name is Rafaela. I am a developer advocate intern here at CrateDB. I am originally from Brazil, but currently based in Vienna, Austria. And I'm very excited to co-moderate the second edition of the Community Day together with Maria, and cannot wait to see what our community has in store for us. Let's all unite to share knowledge, collaborate, and celebrate CrateDB. So, Maria, exciting topics are coming on this Community Day. Can you give us a sneak peek of what's ahead of us?
Yeah, exactly. But before we go into this, actually, we would like to learn where you guys are coming from. You can use the webinar chat to tell us where you're based and where you're located. We're very curious to learn. And Rafaela, great question. So what Community Day is about? So today we are gonna learn a lot about CrateDB ecosystem and how you can maximize your data potential with CrateDB integrations. We have very great speakers from Metabase, Apache Flink, Kooky, and of course CrateDB. And today we are all going to learn how CrateDB can be used with a variety of tools. So Rafaela, can you tell us a little bit more about speakers and agenda for today?
Yes, so today we're learning about these integrations and use cases from the very best. And this is a sneak peek at our speakers for today. We have Dmitry Bogoslavsky, the CTO and co-founder, and Konstantin Lyuty, the head of engineer from Kooky. We also have Timo Walter, a senior software engineer at Apache Flink. We have Luis Paolini, a success engineer at Metabase, and Mario Strivisa, senior software engineer at CrateDB. We'll get to know them all a bit better later on, but for now, let's take a look at the agenda for today. In the first section, we will explore how CrateDB and Metabase can be used together to perform real-time data analysis. Then we'll learn how Kooky uses CrateDB to get insights from large amounts of data. We'll also learn how CrateDB fits its toolchain and how it integrates with other open source tools. Our third talk introduces Apache Flink and Flink SQL in their capabilities for stream processing. And our final talk is a live demo of Apache Flink with CrateDB as a source or sink. In the end, we'll have a 10-minute Q&A section where our panel of experts will answer any questions you have about the topics that were covered in the webinar. So feel free to share your questions anytime in the Q&A section here in Zoom or in the chat. So it's time to dive into our event. Are you looking for a powerful combination for real-time data analysis? Then get ready for our first talk. Maria, can you tell us more about our first expert?
Yes, absolutely. It's my pleasure actually to introduce you to Luis Paolini, a success engineer at Metabase, who is going to tell us a little bit more about how to analyze data in a real time with Metabase and CrateDB. Luis will introduce Metabase and will show us how Metabase and CrateDB can work together flawlessly. Welcome, Luis, and looking forward to your talk.
No, thanks to you. Really appreciate. I'm really grateful for your invitation. The entire team of Metabase is really grateful for this. So thanks to the CrateDB team for making this happen. My name is Luis, as I was introduced before. I will try to do just I would say a little demo and a little presentation about this powerful tool which is Metabase that will really allow you to do self-service analytics, this holy grail of analytics that everyone talks about and no one like managed to reach yet. Like I can for surely say that the users and customers of Metabase are really happy and that they achieved self-service analytics with the tool. So I'm gonna try to wrap up and do a brief presentation about how to try to achieve this holy grail, this chimera of analytics with Metabase, and in this case with CrateDB. So for anyone that doesn't know what it is, what Metabase is, it's just, you know, a very simple and powerful tool that makes or gives the possibility of everyone to dig into data. Even less techy users, the possibility that Metabase will gives you, and I'm going to show it in a few minutes later, is that you don't need to know SQL to go and dig into your data, which is, you know, you give non-technical users, I would say, this amazing power of digging into data and start like doing drill downs and drill through. So this is a dashboard that you can achieve very easily. I'm going to do a simpler dashboard than this one in just a few minutes, but you'll see that it doesn't take you more than 2 minutes to reach a dashboard in Metabase, which is pretty awesome. How can you run it? If you want to do it like right now in your computer, you can just go and do a Docker run, and it will, you know, it's a 300 megabytes container. You can pull that depending on your internet connection, you know, in a couple of seconds, and in no more than 60 seconds, you have a full-fledged analytics platform ready to rumble in your machine. Or you can even, if you have Java installed on your machine, you can even use the jar file. You know, it's just running one of those commands. If you want to run it in production, well, this same container or this same jar file that you can put in your machine can even be put into, you know, a cluster of containers anywhere you want, or a cluster of servers, and it will literally scale horizontally pre-linear. So you'll have again a production cluster of Metabase that can you know, sustain, I don't know, several hundreds of thousands of users. We have customers, in fact, that run Metabase with, you know, a team of 10 people, and we have other customers that run with teams of thousands of people in their companies with just the same application. Just that, as simple as that it is. And if you don't want to get into, you know, the burden of running Metabase locally, or, you know, starting deploying containers and stuff, you can even use our cloud. Like, just go to metabase.com, just click on get started, and in no more than 5 minutes you'll get a Metabase instance running with all the, you know, the bells and whistles, all this, you know, the highest security standards, so you can get up and running very quickly with a Metabase instance. I give you a link there so you can check what do we do security wise in Metabase. And now let's dive deeper. Let's go to the demo. So here is I'm gonna tell you a happy disclaimer. So absolutely everything that I will do here right now, first of all, you can pull the demo that I prepared, which is on my personal GitHub repository. You just pull that code, you do Docker compose run, it will spin up a CrateDB, it will spin up a Metabase, it will connect those two automatically, it will set up the Metabase instance also automatically, and you'll have everything up and running, just as easy as that. And absolutely everything that I will do here, you'll see me doing here, can be achieved with API calls. So Metabase, I love to say that it's an open API platform where absolutely anything that you can do on the GUI or on the web browser, it is also an API call. So we have customers that automate things like the provisioning of Metabase, you know, the provisioning of users, the provisioning of permissions. Like, literally, they ask questions, they create dashboards, absolutely everything programmatically, which is awesome. Literally, it's awesome. So let's go now from zero, completely zero, to some data. Again, I have a Metabase instance running on my machine. Let me go to this tab, what I have here. Muted? I was muted? I didn't know.
You're back now.
Oh, cool. Thank you. I don't know what happened there. So Metabase got into the CrateDB, got all the metadata from it, and it's gonna tell me like, do you want to do explorations, like automated explorations of your data? So if I click, just like in this table that Metabase found, I just have an automatic dashboard of what is going on in this table, like without any effort. But let's dive a little bit deeper, because sometimes you might want to do something else, like I want to see the orders by by month, right? I mean, the count of orders by month. Let's change the visualization to a bar chart, and boom, I didn't need to run any SQL, right? Metabase did all the heavy lifting without me having to do anything else. Let's try to do maybe another question based on the orders table. And by the way, Metabase also suggested me that if I wanted to do a question based on the question that I did previously, Metabase will build a CTE, right? So it will build a question, and it will be give me something from this SQL that you created before, right? So it's pretty awesome that I didn't need to do absolutely anything. Metabase will do all the heavy lifting around the SQL that it's running underneath. So let's do maybe an average of the total, again, also by, I don't know, maybe by the created app, right? But this time per year or per quarter in this case. Cool. So I have two beautiful visualizations that I can use here into maybe a dashboard. So I went from completely zero to a dashboard, as you can see, in less than 5 minutes. Okay, so let's put dashboard 1. Good. So I have 1 question, 2 questions. I can resize them as much as I want. Boom, and there we go. We have a dashboard. I can maybe add filters to this dashboard, because it's pretty easy to do. Let's maybe add a filter. Oops, I didn't pick the correct filter type, which Metabase easily told me. So let's pick maybe a filter of all the options by time. So give me the created ad. There we go. Just as simple as that, I can start putting filters on a dashboard, and users can come here and interact with this dashboard without any effort. Nice. Now let's move a little bit more, in this case, to models, because I used, in this case, for this demo, the database that it was kind of like a raw, and people literally don't care where data comes from. They literally need something descriptive. They need something that you can go and see, like, I want to get my data from this entity, however it's going to call. I really don't want like maybe a field to be called P underscore something. They want that field to be named whatever they are looking for, right? So Metabase will give you that possibility as well. So let's say that I want to give my users the possibility of having to see all the orders by the people without having to do those joins. Who knows? I mean, people don't know maybe what a join is in database structures, right? So let's give the users the possibilities of just going here and saying, I want to ask a question via a simplified version of this join, right? So let's do orders plus people. And now when we save this question, let's save it as a model. So I'm going to turn it into a model. And starting from now, this is going to be something that people come here and say, oh, this is, it's as simple as that. Like, this is an entire structure. Metabase in behind the curtains is doing all the joins and everything. But this is a very simplified structure that now people can come and say, okay, so now let's see maybe, the sum of the total per the state where the people are, right? And there we go. Metabase will even provide you with a state map, because in this data set that I provided, it's has a state map of the US, and Metabase knows that because of the metadata, and will give you a map of the orders by state. So as simple as that, I was able to create some data or metadata above my raw data, which is pretty awesome that you can do this at the application level. Let's add this to a dashboard as well, so we can keep our dashboard pretty with some map. Cool. Let's move now from models to questions. We created a few questions there, and they're already there. But questions can have more than just the charts. They can have settings. They can have metadata. You can start doing things like if I want to turn this question into a model, maybe I can put that model into the database back. I mean, Metabase can go and write back to the databases if needed. So in that way, you kind of create a materialized view, but at the Metabase level, at the application level, rather than having your data team go and write SQL or prepare those materialized views at the database level. So this is pretty awesome. Also, I can start adding descriptions. This is going to be a reference question from now on. People can start, and I'm gonna show a little bit later, things like verifying questions. So now if you see, I can go and see that this is a verified question, that it's for anyone to see. It's differentiated from all the other questions. I have the data there. So again, you can start putting metadata over your entities or whatever you created in Metabase, which is pretty awesome. It gives you a lot of power on how the entities are organized inside your Metabase instance. Something that I didn't show before is the possibilities of also like putting more metadata into the model. So let's say that I want to give someone the possibilities of saying, this is the field that has the ID of the customer received from the CRM, right? So I can do things like this. Whenever I save this, now people can come here and say, like this, it should have a description there that I just put. So maybe that's a little weird bug that just happened. Maybe I didn't refresh it. But this is like, you can put more descriptions and start adding metadata into your models, maybe into your fields, changing everything here. Again, it's more metadata that you are to your users that they can easily find inside the product. Also, there's a data catalog. Sometimes we don't show this, or it's like a little bit hidden, but you can also go to the raw table and say, people, this is the users table. And the same as the address, address in the US. And once you end up, writing everything, you can now go to, for example, browse data, check here, learn about your data. Once you go to the tables, you see that just metadata that you put over there, right? So again, more organization over the entities that you created to help your users find what they need, right? So it's just the address in the US. Cool. Now, we created dashboards. Dashboards have a really amazing possibilities of giving your users not only the ability to see them, and every single time you click on the dashboards, Metabase will go and run this dashboard in your database, but it also has the possibilities of building subscriptions. So this is something that you can configure per user. You can configure, for example, filters, and you say this dashboard with this set of filters is going to be sent to this group of users. This dashboard with these other filters will be sent to many others, right? And also the possibilities of embedding this. I haven't shown this. Yesterday we had also some chat, in the Metabase team about embedding. You can embed all these dashboards and all these questions in any application you wish. So that's another possibilities of the dashboards. You get drill down over here, so you can keep drilling and do things. Oh, I just got a little bug there over there. But again, things like this happen. I can go maybe and drill in these orders and dive deeper into this into these dashboards. And the final, the cherry on top, I would say, is everything about governance. So I just show you the possibilities of just validating a question. You can also say, okay, I'm gonna maybe pin this question over here because I want to see it more on top of my collections. But also the possibilities of building a collection. Say this is the official collection, and you see like this collection will be differentiated over all the others. So there's governance over this. And again, when you give the self-service power to the users, things can get pretty messy pretty fast, right? Because anyone will go and create it on stuff. So once that happens, you need to start thinking about governance. Metabase gives you these possibilities of official collections, verifying questions, so users can find easily what they are looking for inside a Metabase instance. Just to wrap up and to finish, and I'm gonna finish. So as you've seen, a 60-second setup can run from a Raspberry Pi, of course, a single user or just a couple of users, to maybe a cluster serving thousands of users. It's as simple as that. My computer is, this Metabase in my computer is eating, how much? It's eating 600 megabytes of RAM right now with everything I did, like as easy as that. You can go from 0 to dashboard in just 5 minutes. It's, it's what we did here. There's no more complexity than that. Anyone can go and ask questions on the data. In fact, I haven't shown, but in Metabase, you can also write SQL if you want to write SQL. And even the SQL questions can be used by the GUI. So you can start playing around with SQL, with GUI. Both teams, maybe data teams and maybe non-data people, can play between each other, with this 2 types of questions. Everything is an API call. You can automate whatever you want in Metabase, from the instance creation to the dashboard creation to the permissions. Absolutely anything can be automated. And as you've seen me using here, it's really, really easy to use Metabase in order, once things got created, to do governance over what you did. So if you have any questions, any help, like, just write to us, write in our forums. We have a very active forum discourse. Contact us at hello@metabase. We'll be super happy to help you achieve your goals with your data. Thank you very much. Pass the ball again to Rafaela.
Yes, thank you very much, Luis, for this very interesting talk on Metabase and CrateDB. Dear attendees, please write your questions to Luis in our Q&A section. We have some time to discuss them at the end of our event. And now we continue to our second session of the day. And in this talk, we'll hear from Dmitro and Konstantin about their real-world use case with CrateDB. They'll share how CrateDB helped them analyze and gain insights from large amounts of data and how it seamlessly fits into Kooky's toolchain. They'll discuss how they've integrated CrateDB with other open source tools for a comprehensive data management process. So let's dive in. I am pleased to introduce Dmitry Boguslavsky, CTO and co-founder, and Konstantin Yuti, the head of engineering at Kooky. So Dmitry and Konstantin, welcome to the second edition of the Community Day. Are you there?
Yes. Thank you very much for the introduction.
We can hear you. Great.
Let me quickly share. All right, you can see my screen, right?
Yes.
Perfect. All right, thanks a lot. Great to be here. Dimitro, CTO co-founder at Kooky, with me, Kostya, Konstantin. He's the head of engineering at Kooky. Well, I think what's important to tell about Kooky, it's a very heavy hardware and software, of course, oriented solution that is focused towards consumers. I think it's just important to tell a little bit about that. So we are working on tracing and operating reusable food packaging in a circular life cycle. So different to, for example, also the Metabase now presented in self-service setup. This is very heavy hardware work. So we have multiple objects, components of the systems that are in real time connected to each other and connected to our backend systems. And so we are keeping track of our food packaging. So what's the case is that packaging today is one of the biggest waste producers on the planet. And we decided to tackle that by creating a solution that is using reusable packaging in circularity. So it's not recycling. We are actually, with the example of coffee cups that you can see here, we are handing out coffee cups, which consumers bring back to us. We wash them, we repackage them, and we bring them back to the outlets. Now, all of these steps have specific caveats or issues that one needs to handle, especially when our target is to do this in real time. Because when consumers are picking up packaging and they bring it back, When they pick it up, they pay a deposit. And when they bring it back, they want to get their deposit back. And this deposit needs to be brought back instantly. It's not possible in today's world that people are waiting for it like for a day or a couple of hours. They need to get it right away. And so we have a complex system that has many of these components and a continuous moving object. We have subjects of users, we have subjects of outlets. And so this creates a complexity in which we could only go to one single architecture type, which was, of course, a microservice architecture that we went for, that you can see here. So this is our situation that we had to deal with. And of course, as you know, we have to like the positive side of a microservice architecture is that we can, of course, handle every service standalone with databases inside, and that helps us to, especially with the inserts. But as soon as you try to create specific features that require the whole system to work with, it has, of course, issues. We would need to create a lot of joins to actually get out information about how a single user interacts with single outlets on a continuous basis. And while this is possible in downstream in the data setup, we want to do this in real time while the users are using it. And so for something like this, we had to actually we had a specific challenge that we needed to tackle. And most it was about CrateDB querying. Now, I think this is quite well known, and it has a very low performance. Like for us, the real-time application that we wanted, well, actually CrateDB came in very handy, was a loyalty system that we wanted to run for our consumers. Now, every time you brought back like a coffee cup, we wanted you to get specific loyalty points or benefits, but we also needed to know how many you had before, in which status they are, the previous ones that are today. And so it was really difficult to go through all those parts. We needed a single place where we can actually pull that all off. And we had to pull this off at the moment you brought back the cup, not later on to just review the information. So the moment you brought back, we had to like pick up on the benefit that you received. And how this is possible, of course, nowadays to solve this, for example, data duplication, it requires a lot of management, and you can get issues in it. And when you're dealing with currencies, values like monetary values, wallets, people are not happy if they even miss like a single cent. So it's something that with data duplication, things can go wrong. And it's such a granular system, like such a fragmented system, like it will be a problem. So we had to go for single responsibility. And so we wanted to know like what would be the solution. And what we went for was CrateDB. And it helped us really a lot to be able to integrate it into our architecture in a more easier way, running it on the side, constantly reading from the RabbitMQ. Maybe, Kostya, you can tell with, well, for a second how the RabbitMQ setup is.
Yes, actually, that's a bit about how we integrate CrateDB into our system, into our architecture. So we have microservices approach for our system, and all the communication between microservices are asynchronous, and we use RabbitMQ to communicate between different services. And to integrate CrateDB into our system was quite easy because we just start up a new service, and the service we connected to the RabbitMQ. We just needed to only a bit to enhance the messages that we send between services, and we just consume all messages we have in circulation by this we call data repository service. And
absolutely.
Yes, and then we can just easily insert data into CrateDB. Sorry.
Yes. Just also, I think we will in a second explain also how exactly we went for the CrateDB setup. Just to, of course, showcase you like this complexity inside of this is really going from public services, closed services, mobile application, admin interfaces, our boxes that are on the streets, our dispensers that are on the streets. All of that had to constantly be on the run and on the constant connection. And these specific logical, so it's was not only about registering, it's also really understanding the benefits of the loyalty system that we wanted to apply. And with this give you an introduction to the loyalty system itself is that the sequence was especially focused on spatial data. So it was dependent where you picked up the cup, where you brought it back, so that you can actually receive a specific benefit out of it. And what benefit you received, why you received it, what was the amount that you received was always dependent on which box you took or from which outlet you took the cup to which box. And so this was one of the more difficult parts on the loyalty system itself. So we went for also pass-through construction and clusterization of, have you picked up constantly at the same outlet your coffee, and with your coffee cup, have you brought it back to the same return box or not? And if you brought it back on the same path for a repeated number of times, you will actually be able to receive specific benefits that were, let's say, personalized to you. And all of that has to, of course, run not only in the numbers or in the types of objects, it was also the values. So we have different currencies and different wallets. The user can have two wallets, different currencies. You could have a euro and a Swiss franc. So this was not as an easy solution. And with CrateDB, it was for us extremely easy to have a single place where we could query through our entire system, whatever we needed within a mere milliseconds at any moment in time, which was simply impossible before that. So we almost, as we were running a circular economy, we even created the circular inside the system by inserting through a microservice architecture, but reading through CrateDB in the complex query setup. And now I would give over to Kostya entirely to explain how the integration was working, or how we actually moved forward.
Yes, thank you. So I will just go a bit more deep in the technical side of our system. And yes, as I said, that we start up the new microservice for the CrateDB connected to the RabbitMQ that we use in our system and consume all messages that actually circulates inside our cluster. For each message, we can do like any insert or update, and that's exactly where we can use the benefits of CrateDB and why it actually was really a good solution for us. So our system is done on Java language, and we use most typical Java framework, Spring Boot and Spring Data JPA to access to databases. For most of our services, we use PostgreSDB, and the same approach we used for Crate, and that's exactly that Crate is compatible with PostgreSDB. So we just like a very few manual changes. We need to set up like a proper Java class name, proper Hibernate dialect, and it works almost out of the box. And for the incoming messages, we just implement like a very simple CRUD operations like insert, update, delete, and simplest queries using Spring Data JPA, and that actually works. From the other side, for complex queries that Dmitry mentioned about spatial search or for some aggregation queries, we used Lucene library, and that's exactly why it's easy to work with CrateDB, because it's compatible with Elasticsearch queries, and we can build really smart queries based on this approach. Maybe I can go to the next slide, Dmitry. And just about few takeaways that we get from technical side of CrateDB. So it's good to have all data in one place. We use several tables, and we can do like a cross tables joins, and it's really easy to get all the data in one query. We use both approaches to work with CrateDB, SQL and Lucene. And also the second really great benefit that we can use cloud version of CrateDB, and even better for us, we can use cloud version from the same AWS region that we use for our main system. That's actually Frankfurt region, and it actually works in the same region. So we have like a great performance, and we have like a really quick response time. What actually some maybe missing or some features that could be improved, that actually it's really a bit missing the transaction approach that we use in Postgres, especially for updates or simultaneous updates, and not all our libraries that we use to work with databases is fully supported just because of some internal Postgres tables or role management is not exactly the same as in PostgreSQL. And yeah, I guess that's it.
Absolutely. Yeah. So as you can see, our way of integrating CrateDB really went for the complexity within this microservice architecture, and it was really helpful to go for it. We removed a lot of pain. We can actually could focus on the solution itself and didn't really need to dig into database setup or data management as much as we would need to do it without. I think very important to say what is great is the loyalty system, the actual visualization that you saw before in our applications, in our consumer application, is directly straight coming from Crate. So we cannot deal with any type of downtimes. People don't see that. That's really going to be a problem. And I think this is important to say. We have not observed any service interruption or downtimes from Crate. And I think that this reliability is something that most businesses can rely on. And I can personally say I was very happy to see this type of performance. So thanks for that, also Crate. And yeah, that will be it. Happy to answer any questions that will come up.
Thank you, Dmitro. Thank you, Konstantin, for the very insightful presentation and a lot of details. It was really great. And please, if you have further questions for Dmitro or Konstantin, use our Q&A chat. And I think now it's actually time for our third session for today. It's my pleasure to introduce Timo Valta, a principal software engineer and program committee member at Apache Flink. Timo is going to introduce us to Apache Flink and Flink SQL, and also to tell us what it means for Apache Flink to be a general streaming processor. Welcome, Timo, and I'm looking forward to your talk.
Thank you very much. Yeah, welcome everybody to this community day. Let me share my screen and then we can get started. So yeah, this talk is about Apache Flink and Flink SQL. Let me also introduce myself a little bit. So I have basically two CVs here. I have an open source CV. I'm a long-term committer of Apache Flink, even before it became part of the Apache Software Foundation. And yeah, I'm among the core architects of Flink SQL. And career-wise, I was part of all the founding startups of Apache Flink, Data Artisans, Verica, co-founder of Immerok, which got acquired by Confluent early this year. So let's get started with Apache Flink. What is actually Apache Flink? So maybe you have heard of Apache Flink already. It has something to do with streaming, something to do with real time. But let's get into the details. What is actually stream processing? If you want to do real-time processing, you actually always need those four building blocks here. First of all, you want to deal with streams, right? So you have some pipeline from source to sink. Maybe you want to distribute streams because you have a lot of data, so you want to scale out or scale in. Maybe you want to join streams together. Maybe there is a controlled stream and you want to enrich stream, or you want to have some machine learning model. You want to maybe classify the stream. Then you might want to replay streams. Maybe there was a bug in your application and you just want to replay something. Then time is a very important component in stream processing. Sometimes you want to synchronize two streams based on time, but sometimes you still want to make progress. Sometimes you need to wait and buffer events. Maybe you want a timeout if a second event doesn't come in time. Sometimes you just want to process historical data, so you want to do fast forward of time, and sometimes you just want to replay the time. A very important building block in Flink is state. State is the unique feature of Flink. First of all, you want to store some data, maybe some records. Maybe you want to buffer events until you want to evaluate them. Maybe it's a cache so that you don't have to go to the database all the time. Maybe you want to store a machine learning model. Maybe you want to have state that is big, like in the order of gigabytes or terabytes. Sometimes you also want to expire states, so due to GDPR restrictions. And whenever there is state involved, actually what you would like to have is some kind of snapshot. So you want to back up the entire topology. You might want to save those snapshots in different versions on a disk. Maybe you want to fork your streaming application and try out different business logic. Maybe you want to do A/B testing with different versions of your application. And of course, you maybe also want to time travel and also restore those snapshots from time to time. All of that is possible with Apache Flink. And people often ask, so, but what makes Apache Flink so unique? So let's assume we want to build an Apache Flink a pipeline. So actually, you can design a pipeline like you would draw a data flow on a whiteboard. So you have some sources, some operations like normalizing data or filtering or joining. What Flink does for you is all the heavy lifting in the background. So you don't have to deal with parallelism. You don't have to deal with threading or with serialization or with all the or RPC calls, like all the distributed nature is hidden behind the API. But in the backend, there is a data flow engine, and each operator can have some state. The state is local to each subtask. So that means the state can scale in and scale out with the operation, and it's also fast because you don't have to go through the data to a database, which would increase the latency. And yeah, between those operators, events are traveling. And what makes Flink unique now is that from time to time, Flink can make a consistent snapshot of the entire streaming application to a durable storage. So with this architecture, what can I use Apache Flink for? Like the use cases are very, very diverse. You can have, first of all, you can connect different systems, messaging systems, file systems, databases, and key value stores. For analytical purposes, for data integration, so Flink can serve like a data hub between systems. You can just do ETL operations from Kafka into databases, for example, and you can also do event-driven applications that react on certain events and send out an email or whatever. Like the framework is very, very flexible about this. People also often ask, like, who is actually using Flink? And this is actually not easy to answer because it's an open source software, but we have a Flink Slack channel. You can also join this Slack channel if you want to. And there, like, sometimes people or users also introduce themselves. And as you can see, we see the big names here. Some users use it for internal cloud infrastructure, for security products in real time, for streaming feature platforms, real-time processing for online games. Yeah, like the use cases are very diverse. Let's also take a look at the APIs of Flink. So this is a rough API stack that we offer. Under the hood, there is a unified data flow runtime. On top of that, there are different abstractions. So the main API is the data stream API. In the middle, you can see the table SQL API. So it is possible to define a data flow in SQL. Underneath, there is an optimizer and planner, which tries to make it as efficient as possible for you. And there is also stateful functions, which gives you like a akka, similar to akka actor model on Flink. So here is also like a simplified example of the data stream API. I don't want to go into details, but yeah, you have like some runtime mode because we support both batch and stream processing with the same API. So you can use batch processing for processing historical data, and you use streaming mode for real-time, unbounded, infinite data. And yeah, in this case, we are just creating a stream from 1 to 3 elements and printing this to the client. The important thing about Data Stream API is that it exposes the building blocks that I mentioned earlier for stream processing. So you can create arbitrary operator topologies, and all the business logic is basically written within like some predefined endpoints, like a map function, a filter function, a process function, a window function. And you can also just arbitrarily select the records that flow between the operators. So just regular Java POJOs. And conceptually, this API is based on an append only or insert only log. So when you print this on the console of your IDE, you will simply see a 1, 2, 3 printed to the console. So let's take another look at the second most important API, which is the SQL API or table API. So it is up to you which API you want to use. You can either do it fully programmatically, like in the example above, or you can also use the standard ANSI SQL to define your pipeline. So in this case, again, we are creating 3 records, 1 to 3, and then we are just selecting those from the virtual table, and we are printing this to the console. Compared to the Data Stream API, the SQL API or Flink SQL tries to abstract the building blocks for stream processing. So you don't see state or timers or anything like that. It's all abstracted under the hood. And also the entire operator topology is basically determined by the planner. The business logic is just declared, and the optimizer tries its best to make this possible. And the interesting concept here is that under the hood, even though a user works with tables, under the hood there is a changelog happening. So we are actually dealing with changelog streams or CDC streams in the SQL engine. And this also brings me to a very interesting topic that a lot of people are interested nowadays, is like CDC stream processing, because databases are well known, and how can I actually connect to a database and make my batch world a little bit more real time. And let's talk about like how can I actually work with streams or CDC streams with Flink SQL. So I already said it. You don't work with streams in Flink SQL. You work with dynamic tables. So dynamic tables is just a concept. It's a logical concept. It's a concept similar to materialized views from databases. You define tables, like in this case, we have a transaction table and a revenue table, and then you define a standing query up front. In this case, it would be a summing and a grouping by name of the transactions. And it feels a little bit like a database, but actually Flink is not a database. You bring your own data and your own systems, and Flink connects to those systems, and it's just the database engine, basically. So how can we actually, if we only work with tables, like how does it match together? Like how can we connect streams and tables and do CDC processing? And here I brought an example how this happens under the hood. Let's assume we have a table transactions, and there is a Alice coming in with an amount. In the changelog, in the stream, for example, in a Kafka topic or a RabbitMQ topic, this would be an insertion. It would go into the engine, and then the engine would produce a changelog event as in the output stream. And if you would apply this changelog to a key value store or to a database, then you would actually get the final result table. And this process is called materialization. So let's do another example. So now Bob comes in. Again, we are producing the sum, and then we are sending it downstream, and we are putting it into the table. And now comes the important piece. What happens if there is a second Alice coming in? So the sum actually needs to be updated. And we are doing this by first removing the old record. So there might be a deletion coming out or an update coming out of the engine. And if you apply that, you would delete the row in the downstream system and insert the updated row. And under the hood, there is, for example, Flink state used to keep the count in a fault-tolerant manner within Flink. So Flink takes care that this count is always exactly once, even in case if a node goes down. So Flink is very large, and like 15 minutes are not enough to really explain Flink or Flink SQL in detail. What I can tell you is that Flink SQL engine is a very powerful changelog processor. I have brought you some examples. All of these examples are standard SQL, and they solve like quite frequent use cases. So on the left side, you see how we can define windows, like we can cut the stream into pieces and perform aggregations on windows. The bottom one shows you how we can do stream enrichment with SQL. Based on time. So for example, this example, we are joining the orders table and we are looking up the currency rate, the conversion rate of a currency at the time when the order happens and stuff like that. So like very sophisticated logic, but that is actually very useful in real world applications. And on the right side, you can see pattern matching. So you can search for patterns in the stream. And once this pattern, similar to a regex, once this pattern has been found, then, for example, you can send an alert downstream into the table. So in general, Flink SQL is a flexible tool for integrating systems with different semantics. And yeah, we have a large coverage of the SQL standard. So yeah, if you're interested, I would recommend take a look into the Flink documentation. There is also a lot of content on YouTube, a lot of conference talks, a lot of walkthroughs and tutorials are online. And yeah, there's also the Flink channel, Flink Slack channel, if you have any further questions. And yeah, that's it from my side. And yeah, I'm looking forward to any questions about Apache Flink. Thank you.
Thank you, Timo, very much for this interesting talk introducing Apache Flink and Apache SQL. Dear attendees, please write your questions to Timo in our Q&A section. We'll have some time to discuss them after the next talk. And we move forward to our fourth session of today. Marius will show us how to integrate Apache Flink with CrateDB as a source or sink. We'll learn how CrateDB and Apache Flink can work together to handle large volumes of data in real time. I am very pleased to introduce Marius Trivisas, Senior Software Engineer at CrateDB. Marius, welcome to the second edition of the Community Day. Are you there?
Yes, hello. Thanks for the introduction.
With you.
Yeah, let me share my screen. Can you all see my screen? Taking from Timo's introduction, I will show how you can connect Flink with CrateDB in some different ways. And just to let you know that I will provide a couple of slides with links to all the relevant repositories with the code and some links to documentation. So to start off, I have a simple example on how to use the table API that Timo mentioned already to connect with CrateDB. So first, you just define your connection settings. I have already a CrateDB instance locally that it's running. First of all, we can just easily see what are the tables that are listed in our database, and here is the list. So then we can do a simple insert on a table. We can see that our table is empty at the moment. So I have inserted those records into the table, and all those are a new event, as Timo mentioned, the CDC, the changelog, and I can also see those records, of course, in my database. So to move on to check what you can do with the table API, instead of using SQL, you can use the Java DSL to select a specific field and do some processing on top with some built-in functions, but also Flink provides you with the opportunity to create your own functions for processing things. So we go into the table we already saw, and we just take the length of each string, we trim a leading character, and we get the length of it. So next, another example. Sorry. Where we have a different table T2, which in the beginning it's empty. Then, in the beginning it has already 5 values. Then we can insert more values using the SQL language, and then we select it again, and we see the new values 6 and 7 that are added here. Next, we can do some counting. Sorry. And here you can see the example that Timo mentioned already, that you have this is processed as a stream. So with new records coming in, you have inserts, then updates of the values until you end up with the final count. And if you want to see that, how it would look with not a stream, but with a batch job instead, where you process the data in a different manner, then if we run this again with a batch mode, then you just get the final result back. So some more complex things you can do with the table API is to union things. So in this example, I'm just using again the same table and apply some filtering on top. So the table had values 1 to 7. I'm duplicating those, but I'm filtering everything greater than 4. Next, we can see the same result by using the plain SQL syntax and query. So we get the same records back. And another important thing that you can do with Apache Flink is joining. And of course, you can join your stream that it's coming together with some lookup tables that provide some more static information to enrich things. And in this example, you can see that I'm producing actually a virtual table from a stream. I'm joining it with existing table in the database and the join condition. And if I execute it, you can see the result here with the joined, the fields that the values that matched. Another example, which would be very useful, is to do an aggregation. So we have a table T3 already in our database, which has some values. So we're grouping by the name value, and we calculate some min, max, and average on that. And here is the result table, again, with all the events from the change log as it starts reading records from the table. And again, we can switch that to a batch setting, and at the end we can insert to a target table, which is T4 in this example. And we can see the results written here from our aggregation. Here is just a query with Flink code to do that. I will skip it. And finally, an example on how to convert your a table from the table API into a data stream, which of course, again, you can, as Timo mentioned, you can do whatever you want on top of it, like filtering, processing, and whatever business logic you want to apply. So in this example, let's first comment this out. I will just select all the values from T4 and create a data stream out of it, which then I can easily filter out. For example, I will just get back the record that ends with DB, which is here. Or maybe I can do some other processing, like get the second column only and multiply it by 10 and print it out. So there was also some work involved here because in order to make this work, we need to use the Flink JDBC connector, which currently doesn't support Crate. And there is an open PR with the code necessary to implement this. And for the purpose of this demo, I'm just using a local build of this branch that I have to make it work. To move on, another example would be to not use the table API, but use the more traditional sync method. So you can have your streaming program that processes the records as they come in, and then just insert them into a CrateDB database. So here is an example like that. So we have several elements that are also mapped into a Java class to make our lives easy. And then at the end, we add our sync, which is a JDBC connection. And here you can see that we are able to use the vanilla Postgres driver instead of our own one, which is needed for the table API at the moment. And also, there is another thing that I need to mention, that the table API currently you cannot use custom schemas for the tables. So in the previous example, we are using the doc schema, which is the default for CrateDB. But with this code, with the sync, you can use the random, any custom schema that you want. So let's take a look at this table, which should be empty at the moment. So by running this program here, I'm going to insert those records into the table. Great. And finally, I would like to show you an end-to-end example where we are using Kafka with Flink and writing the records into CrateDB. And this code is here. So we have our source, which is the Flink. the Kafka, sorry, broker. Then we apply some simple transformation, which is to map our taxi ride objects that we are using here into some payload that we then write into the CrateDB. So this example, we can run it with Docker containers, which to speed things up, they were already running. So we have submitted a job. We publish data, and this data end up in the CrateDB database. And here, for example, we can see the data in this table, and then we can do whatever processing we need to do on top of that, calculate averages, etc. And just a quick glimpse. This is the Flink cluster that has spinned up. And sorry, so this was the latest job here that it was run, and we cancel it through the script. But because there are many records, so we cancel it after the first 5,000 records that are processed. And here, as promised, are the links for all the repos that are used here with the examples. And the last example, there are links to the issues that have been opened meanwhile regarding this Flink JDBC behavior with the schemas. And I've also provided some links to the Flink docs regarding the JDBC connector, the table API, and the data stream API. And that's it.
Thank you, Marius. If you have questions for Marius, please use our Q&A function. And we are now actually moving to the Q&A session. I can see already several questions, so I will start with the questions that arrived first. And the first questions we got is for Luis. Luis, are you still there?
Of course, here I am.
Okay, awesome. So the first question for you is, can people run Metabase in the cloud, and which cloud providers do you support?
Sure. So just want to do the separation. I mean, you can run it on any, if you're going to go self-hosted, you can run it on absolutely anywhere. Doesn't matter which cloud that supports, or that you can spin up a server with Java, or any cloud that supports containerization technology or cluster. So that's if you go self-hosted. In the case of the Metabase cloud, we have all of our infrastructure in AWS. We run in AWS and in the US. We have customers from Europe that normally choose self-hosted, or they, I mean, we are GDPR compliant. So in case that there's someone from Europe that needs that compliance and want to know a little bit more about how we handle stuff, we also have all the documentation about privacy that we can handle over.
So currently you're mostly running Metabase on AWS, right? Or offering Metabase?
On our cloud, yes. It's okay. In AWS. Yep.
Okay, thanks a lot. And there was another question for you. It's about actually having issues with CrateDB when you tested and try this integration. Did you experience any? Absolutely none.
And that's fortunately because you guys from Crate speak Postgres,
yes,
that's true. lingua franca of databases around the world. So that's great. And on our case, Postgres, it's kind of like the driver where we put all the new features, and the most I don't know if I would say most mature, but the ones that it's really like the best supported driver in Metabase is Postgres. So if you speak Postgres, for us it's life-saving because it's literally just connect, and that would be it. It's magical.
That's great to hear. Thanks, Luis. that was it. Let's see if there are like more questions later on. I would now ask some questions to Dmitro and Konstantin. Are you there?
Yes.
Yes. So there was a question about the features of CrateDB that you find the most useful for your use case. So can you tell us a little bit more about this?
Yes, I guess for us it was clear that we can split the responsibility. So from the one side, we can work with CrateDB as with like a RDS relational database with a SQL for like a basic operations. So, and from the other side, completely separately, we can do like this smart and complex queries. So that was quite cool that we can just split completely these two parts and we use it this way.
Mm-hmm. And there was another question, actually two questions for you. So the first one, why did you choose to use Crate, a JDBC driver, instead of standard Postgres driver to connect to CrateDB? And the second question is like, what version of CrateDB are you currently using?
For version, I just quickly checked that we use version 4.8.1, sorry.
4.8.1, okay.
Yes, and for the first question, I can give the exact error that we had. It was kind of a bit play which setup would work, but in general, when we tried to use the Postgres JDBC driver, we had to use also the like a JDBC : Postgres prefix for connection string. And for this Postgres Spring Data, actually, that we use is trying to run some internal queries, which were a bit more Postgres specific and were failing on a Crate. When we switched to the JDBC driver of Crate, we could use like a JDBC : Crate prefix for connection string, and for this case, it was fine. So it was like a startup successfully, and connection was successful.
Yeah, actually, there is another one question for you. Sorry.
Sorry, just to add something here that. Probably if you upgrade to the latest versions, we have introduced many more tables and Postgres-specific, let's say, functions. So maybe you don't have this problem anymore, and you could use the vanilla Postgres driver.
Awesome, that I would definitely try.
Yeah, great.
Give us a feedback after using CrateDB 5.2, which is our latest version. And there is another question for you and Dmitro. Did you look at any other databases before choosing and working with CrateDB? If you were looking at other databases, which ones did you consider?
I guess the most ones that we considered between Crate and Cockroach database. And okay, why we choose Crate, it's a good question, but mostly because of the first,
Excuse me, can you please repeat again? So you were choosing between Crate and
Cockroach database.
Cockroach, okay, DB, okay.
And the Crate was just because of this compatibility with two standards. That was kind of a cool feature for us.
Okay, thanks.
Yeah,
Thank
just
you,
wanted to give this answer to this question to the question.
Great. So we have two questions for Timo. Timo, are you still there?
Yes, I am.
Yeah. So do I need to program in Java to use Flink? Can you give us a little bit more insights on this?
So first of all, I mean, Flink itself is JVM based. So like Java is the main language, and but you can also use Scala or Kotlin. But we also have a Python API in Flink, and of course, like the SQL Flink SQL is actually an entire ecosystem. So there is a client, there is a gateway, there is soonish maybe a JDBC endpoint. So you don't need to use Java. You can also use pure SQL to define the entire pipeline end to end.
Okay, thanks. And there is another question also for you. So you mentioned event-driven applications. Could you give me an example?
Yeah. So in general, event-driven applications, it's a very wide area. I have seen people building social networks with Apache Flink. So like the Flink was used for like aggregating the likes or the comments or other statistics, and then the update, like the updated accumulated likes was then persisted in Elasticsearch. And in theory, you can also, I mean, I mentioned state, you can put an entire state machine into Flink's state. So you can basically model the entire user life cycle with Flink. Or another example, I think Trade Desk did that at some conference. So they had like a bidding system built into Apache Flink or so. This can be a lot of back and forth communication and event driven logic, like sending an email, sending a push notification, and so on.
Mm-hmm. Yeah, great answer. Thanks for a lot of details. We have one more question. I think this question is for Marius. So, and it's about what type of data can be stored in CrateDB, especially about geospatial data. Is it supported?
Yes, it's supported, and since I was testing a couple of days ago, I can share. Can you stop sharing so I can share my screen?
Okay, yes, sure.
Second. So yeah, you can index geopoints and geoshapes in CrateDB. I just created a table with a simple record here with a polygon. You can define the precision of your index and the tolerance for error, and you can simply select and try to map a point if it falls into the area and get back the records.
Okay, awesome. Can we move forward now?
I'm trying to answer, but
I will take over, no problem. I can force your screen sharing to stop.
Okay, please do so, because
yeah, sure, no problem. So I think this was the last question. Thanks, Marius, for answering it and showing live how geospatial data can be stored. So now, maybe a great extension to this question is how one can start using CrateDB. And I think, Rafaela, you can give us a little bit more details about CrateDB Cloud.
Yes. CrateDB Cloud is a fully managed service that makes running CrateDB easier than ever. CrateDB Cloud is available on all major platforms and is an easy-to-use solution that lets you start and deploy your clusters in a matter of minutes. You can rest easy knowing your data is always secure and available with CrateDB Cloud's fully automated backup and scalability. So with the free tier, you can have a limited cluster that is free forever. No payment method is required to start the free tier, and it is a great way to try CrateDB Cloud for the first time. Now, if you are ready to experience the full power of CrateDB Cloud, take the advantage of the $200 in free credits to try the cluster of your dreams. So Maria, can you tell us a bit more about these two options to try out CrateDB Cloud for free?
Yes, definitely. So like there are two options. The first one is the free tier forever. So it means you can start a CrateDB cluster with, of course, a little bit limited capabilities when it comes to the memory and the CPU, but you don't need to pay or to leave your payment data, and you can run this cluster as long as you like for free. But if you want to try CrateDB Cloud in different scenarios, maybe with different data sets, and you need more capabilities, you can use $200 free credits. And you can actually sign up for these free credits using the link on this slide. So when mentioning that one can use the link on this slide, I think it's a good point to mention what's coming next. And in the next couple of days, you will receive email with all the recordings and slides that we use in this community day. Also check our blog at Crate.io, which will give a recap of what happened today. Last but not least, once we leave the Zoom call, you will get a pop-up survey to give us your opinion about this event and about the topics that were presented, and also help us to make this event even better in the future. And accept this relatively small things. We have prepared a couple of interesting webinars in April. Rafaela, would you give us a little bit more information about what they're about?
Yes, I would like to invite you all to take advantage of our upcoming webinar on real-time monitoring with OCell and CrateDB. You can join us on April 5th at 5 p.m. Central European Time to learn how OCell's real-time monitoring solution helps reduce the environmental impact of infrastructures. During this webinar, you'll discover how OCell uses CrateDB to monitor energy consumption, production, indoor air quality, and much more. So take advantage of this opportunity to see CrateDB in action and discover how it can help enhance your real-time monitoring solutions. You will find the link to the registration at crate.io/event. And I would also like to invite you to join us for an exciting event on April 27th at 4 p.m. Central European Time. Our guest speakers will demonstrate how easy it is to import data into CrateDB Cloud and visualize it for any purpose by easily connecting to a third-party tool. In this event, you'll learn about the various data types and compression options that CrateDB Cloud supports, and how to import data without coding. You will also learn how to connect to the third-party tools, visualize data, and see the recent changes to the CrateDB Cloud Console, which is the web UI for CrateDB Cloud. So also take advantage of this opportunity to gain valuable insights and enhance your data management skills. You can register now and get ready to take your data management to the next level with CrateDB Cloud. To wrap up from my side, I would like to thank you all for joining us today. Maria, do you want to share something else with our attendees?
Thanks, Rafaela. Yes, first, thank you all from my side as well for joining us today. If you would like to learn more about CrateDB and to see how CrateDB can fit your use case and how you can use it in your organization, you can use the first link in the upper left corner on this side to make a free consultation appointment with one of our CrateDB engineers. But also, you are very welcome to join our community, which is very vibrant and very responsive. So here you can find a lot of interesting tutorials and learn about other integrations as well. And of course, ask any questions you might have about CrateDB. Finally, if you like the CrateDB as open source project, don't forget to give us a star. Thank you again for being with us today, and we hope to see you next time.